Good afternoon. I welcome everyone to the webinar series of the European Meteorological Society. I am Vesna Đuričić, the president of the Croatian Meteorological Society and also one of the organizers of this webinar series. Before we start with today's presentation, I want to tell you a few technicalities. First, please note that the webinar is recorded for later publication on EMS YouTube channel. All webinars which were held on YouTube channel, and this also will be. The second important thing is that you can ask questions by typing them into the chat. After the presentation, I will read questions out loud, so you can start typing your questions from now on. Today, we have a very interesting topic, citizen science, blending National Meteorological Services observations with crowdsourced observation. This is about the contribution from volunteer observations that is a meaningful addition to gridded data sets for 5 different user-requested climate variables in the Netherlands. Our speaker today is Gerard van der Schrier. Sorry if I pronounce it not correct. He works as senior scientist at the Royal Netherlands Meteorological Institute's Research and Development Observations and Data Technology Department. In that capacity, he is responsible for the European Climate Assessment and Dataset and the EOBS datasets. With his team, work is ongoing to include second and third-party data into the climate services products of the Dutch Meteorological Service and turn its focus more toward the impact of climate and weather. So, Mr. van der Schrier, the floor is yours. You can start with your presentation.
Thank you very much, Vesna, for your kind introduction. And indeed, it's a very Dutch name, so don't worry about the pronunciation. So welcome everybody to this webinar. So in this webinar, we'll be speaking a little bit about crowdsourced observations. And by kicking things off, I would like to make clear at the start that I don't pretend to give you a full overview of what is possible with crowdsourced observations, because this topic is simply too large to handle in only one webinar. So I'll be focusing mostly, or actually only, on applications within meteorology, and also, I guess, also the weather part of meteorology. So not so much climate science. And I think there's a whole lecture or lectures perhaps to be given on the use of air quality data, crowdsourced air quality data, when it comes to and blending that with MetSurv's observations. But that is a topic which we will not touch this afternoon. So we will only be speaking about temperature, precipitation, things like that. So what are crowdsourced data? Let's start off with this very basic question. And I think the variety in citizen science data or crowdsourced data is extremely large. And these are just people who are interested to monitor their surroundings, like people like you and me, who build on a personal weather station to the fence in their backyard and are interested to see what it records. We sometimes refer to this source as a third-party network, in contrast to the first party, which is the Met Service itself. But there are also other sources, like professional sources, but non-meteorological networks, like people who do road maintenance. An example is seen here in one of the Dutch highways. This is an interesting way because it monitors the air temperature and humidity over the road surface, and perhaps also the temperature of the road itself to warn against the slippery conditions. But there are also other networks available, like in nature reserves. So many nature organizations are interested in what the meteorology is in their particular part of a nature reserve, and they have small networks installed in that nature reserve, and that is interesting data as well. And all these data are observed in areas where the Met Service usually do not have any stations. There's of course also another source of crowdsourced data, and these are more the do-it-yourself sensors. And this is a very interesting source, and it's very popular, especially with municipalities and the governments, as it involves citizens in getting involved with their community and trying to monitor their surroundings. So there are many projects funded by municipalities or governments focusing on these do-it-yourself sensors. And they can achieve a incredibly high density in neighborhoods. But again, I'm a bit scared about the quality of those sensors. So we are trying to experiment with that, but I don't have much experience yet with these sensors. So we'll not be talking about that in this presentation. So why use crowdsourced data at all? So the networks of the National Met Service, they do not really sample the urban areas or nature reserves or forested areas or other parts of the landscape. And especially the urban areas, they are very interesting because many people live there, and there is a huge focus on, say, health perspectives on when it comes to heat, for instance. On the climate in the city. So there is a particular need to monitor the urban surroundings in terms of temperature and heat for health officials. Also outside the city, there is a need. So particularly in the Netherlands, where we are starting to wake up to this risk of this increased risk of wildfires. We see a strong demand from, for instance, the first responders to have a better network to monitor wildfire risk in nature reserves. And at the moment, we don't have any measurements there. So what we do is we try to use existing networks of citizens and also of second-party networks to get to grips with meteorological conditions over these areas. So when you're interested in an urban area, say about 10 years ago, what we would do is measure this ourselves. And this is what a colleague of mine did. And he's living in south of the city of Utrecht, which is in the center part of the Netherlands. And every morning he cycled from his hometown through the city of Utrecht to the KNMI, where the headquarters is in the Wild. And he did this on his bike. We are Dutch, after all. And on this bike, he had this sensor. And he sampled the temperature on this particular track. So he had to get out of bed very early because the best time to measure the urban heat island effect is before sunrise. And what he did is, with this data, he used a statistical modeling approach to quantify the urban temperatures. And what you get is a map on the right-hand side for that from that experiment. And of course, this is very valuable. The way we are doing it now is by using networks of personal weather stations. And again, this is the Utrecht area where the previous experiment has been conducted as well. There are some 34 stations in this Utrecht region. And in red, you see the KNMI station at the headquarters of the KNMI. And with these 34 stations from this particular network, the WOW network, the Weather Observations website network, we can actually sample the temperature in the Utrecht region quite well. And when you want to go to other networks like those of the Wunderground network or NetAtmo network, they have a even higher density of stations in this urban area, but are usually more difficult to access as these are commercial companies. So In this presentation, we'll be talking about the WOW network a little bit more, and also about the NetAtmo network a little bit more. And I'll show you some examples of how we use those data in our climate and weather services. Oh. Another reason for using crowdsourced data is that you want to get to grips with strong precipitation events, short duration, strong precipitation events. And like the one you're seeing here on the left in the typical Dutch flat landscape. And I'm a bit sorry about the quality of the diagram on the right, but we received this from Katharina Lengveld from the German Weather Service, and it's actually a very interesting diagram. Because what it shows is that the combined networks of the German Weather Service and other networks our German colleagues can access. What this data shows is that they capture quite a bit of the longer duration precipitation events. But when the precipitation events get shorter, in a shorter duration, the fewer events are captured. And for the 1 hour precipitation events, what Katharina showed is that only about 17% of these 1 hour precipitation events are captured in the existing Met Service gauge network. And that's not very much. So when you want to sample these high intensity, short duration events, you need to go to a much denser network. And here, moving towards a crowdsourced network is the way forward, I think. This is also what our colleagues from the Norwegian Met Service thought. So what they did is they are combining their own network with the NetAtmo rain gauge network for southeastern Norway. And what you see here on the right is in topography, for southeastern Norway, the topography in black and white, of course. And the circles are the stations. The red ones are those from the Norwegian Met Service, and the white circles are the NetAtmo stations. And you see that there's a vast difference in the density of those networks. There are about 50 times more NetAtmo stations than there are MetNo stations. And what the Norwegians do is they use temperature data from NetAtmo to post-process their forecasts. And these forecasts are provided on the er.no website. So here's an example where crowdsourced data are actually contributing to operational services of a Met service. And that is really an interesting example. And some of the post-processed precip forecasts are provided to the civil protection services. So it shows that the Norwegian Met Service is very confident about the quality of these data when they are sharing this with both the general public and the civil protection services. And to give an example of the benefits of adding NetAtmo data in their forecast, I've been given this from our colleagues from the Norwegian Met Service. It shows a 2-meter temperature forecast for a valley in Norway. And what the forecast shows is in this valley, in the central part of the picture, the cold pool, which is on the bottom of the valley, is not really captured. So the forecast gives high temperatures in the bottom of this valley. And superposed on this are the NetAtmo stations, and clearly most of these NetAtmo stations in the valley indicate that the temperature actually quite a bit colder there. So they post-processed the forecast, adjusting the forecast to accurately reflect the cold pool on the valley floor, and that produces the picture on the right. And this is a much different forecast than what was produced initially, and much more in line with the station data of the NetAtmo network provided to the Met Service. So here we see an example where crowdsourced data are really used in adjusting the forecast. And this really has an effect on the quality of the forecast. So what you see here is on the upper diagram, the mean absolute error on the vertical axis, and the horizontal axis, the lead time of the forecast. And in red, you see the forecast of the numerical weather prediction, and in blue, you see the same forecast, but then post-processed using these NetAtmo data. And clearly what you see is that the improvement is most noticeable in the first 6 hours due to the strong correlation with the real-time bias. But a relatively uniform improvement is still exists beyond the 12 hours lead time. And also when you look at the frequency of forecast busts in the lower right diagram, you see that the cases where the forecast is completely wrong decreases quite considerably using this NetAtmo data in the forecast, in post-processing of the forecast. So this is an interesting example of using crowdsourced data. Also, precipitation data are being used by our Norwegian colleagues, and here's an example where a thunderstorm passes over the Oslo fjord. So you see the city here on the diagram, and the circles give the NetAtmo station data. And in this instance, the thunderstorm struck the center of Oslo very heavily, while residents in the eastern and the western parts of the city remained unaffected. And examples like this are used to illustrate the size of convective storms to the general public. So it's a very strong way of communicating what is actually happening weather-wise to the audience. And just to rub it in a little bit more, here we see again an example from the Norwegian Met Service showing NetAtmo data in circles. The coastline of Norway is shown quite clearly, and here a storm passes over from the south over the Oslo fjord. And this visual very nicely shows the agreement between the radar data on the one hand and the NetAtmo data on the other hand. But what it also shows is some of the problems we are having with these crowdsourced data. You can clearly pinpoint the NetAtmo stations which simply do not give any precipitation at all, although the storm passes right over their heads. So that is an interesting graphic showing both the potential of crowdsourced data and also the difficulty in assessing the quality and the usefulness of these crowdsourced data. But for visualization purposes, it really is an interesting way forward. The Norwegians have been very strong when it comes to combining crowdsourced data with the forecasts. I'd like to show also some results where crowdsourced data can be used to monitor weather conditions quite strongly. And in the Netherlands, we are trying to do that using the data from the Weather Observations website. This is an initiative launched by the UK Met Office already in 2015. So we have now about 10 years of data. But clearly in the start of the initiative, the number of stations which participated was not so strong. So it has grown quite considerably in the last 10 years. And an example of how this network looks like is now in the center part of this slide, where in yellow you can see the KNMI stations, so that's the official network of the Met Service, and in black you see the crowdsourced data, and the higher density stations data like here in Utrecht or the Rotterdam area are clearly visible. We are also using perhaps it's interesting, these data to map out the weather on the Caribbean part of the Netherlands. So we're doing an experiment to add these low-cost sensors on the islands in the Caribbean, which are still on the Dutch rule, to simply monitor how weather is changing over those islands. And clearly, it's a wonderful resource, I think, and I hope to convince you in this webinar that about our enthusiasm for this additional data source and why we think this is an interesting way forward for many Met services. So we're very grateful for the efforts of the WOW community to provide these data. To give you an example, my favorite example, to be honest, of why we think this is such an important data source is to look at an example of September 2023. This was a very warm month in the Netherlands, and what you're seeing here are maximum temperatures for the build. That is where the KNMI Met Service is hosted, is located. And you see that there's one day where the maximum temperature peaked over 30 degrees. For September, that is quite high. And you also see that the minimum temperatures in blue here are also quite high, and they nearly reach the 20 degrees centigrade. And as you probably know, that the World Meteorology Organization defined this 20 degrees as a bit of a threshold. It's called the tropical night. Clearly in the tropics, people laugh about this, but for the Netherlands, this is really a high temperature. It's a very sweaty night, and people have difficulties sleeping. So it has lots of health effects. And the question is, of course, how well can we monitor this minimum temperature using our network? So when we try to do that, we get the picture on the left. Where we see a gradient from the coast, where it's a bit higher than the minimum temperature is a bit higher than 20 degrees, towards the east, where the temperature drops just below the 20 degrees. And everywhere you see a mark, one of the automatic weather stations of the KNMI is. And there's one station here doing something strange, but okay. But when we start to look at the uncertainty of this map, we get the picture on the right. And the light colors give you a low uncertainty, and the dark colors give you a high uncertainty. And what you see is that the uncertainty is actually only low in the vicinity of the automatic weather stations. And in between, we are not doing that great. So to improve on this, what we did is we added to the KNMI stations the crowdsourced data. And what you then get is the picture on the left. So again, you see this gradient with warm temperatures at the coast and cooler temperatures more inland, but you see much more detail. You see, for instance, these two darker areas here, which remain a little bit cooler. These are the forested areas in the Netherlands. What you see are the lakes here in the northern parts of the Netherlands. So this is a night in September. The lakes have warmed up quite a bit. And this is reflected in the air temperatures surrounding these lakes. And you also see the cities. So you see the Amsterdam area and the Rotterdam area, The Hague. So you see much more detail in this picture than previously. And for this picture, we not only used, say, the 38 KNMI weather stations, but also about 690 crowdsourced observations. And the benefit of using all those additional stations is that you can do other types of interpolation. So here you can use covariates like distance from the coast, or the water fraction, or land use, without running the risk of overfitting your model. And that is the reason why you find such much more detail in these maps than in the previous slide. And when you now start to look at the uncertainty on the right side of this slide, what you see is that the overall picture is actually much lighter than what you saw on the previous slide. So we are doing much better when we are using crowdsourced data rather than using only the Met Service data. Except for two regions, or perhaps a little bit more, so also on the edges of the domain, we see high uncertainty, and the reason for that is that we are not using data from Belgium or from Germany, so that is clearly a way to where we can improve. But the other regions where you find a high uncertainty are these central areas, these darker areas right here, and these are the forested areas in the Netherlands. And in those areas, we don't have any KNMI stations, and there are not many people living there. So also the number of crowdsourced observations is relatively low. So this gives you the insight that you want when you want to decrease the uncertainty in maps like these, what you need to do is sample the landscape of the country as homogeneously as you can. So, was it a tropical night or not in this particular case in September? When we want to answer that question, and by making a probability analysis and using the standard KNMI network, we get a picture like this, where low of light colors now give you a low probability, darker colors give you a high probability. And when you use the KNMI network, you get a picture like this, where the answer is either yes or no, depending on whether you're close to depending on the weather station. And in between, well, we actually don't know. So this picture is not very useful at all, to be honest. When you do that analysis using the crowdsourced data, you get a picture like what is shown on the right. And here you see, again, much more detail. You see the cities popping up, like the Amsterdam area, where the probability of having a tropical night is very high, the Rotterdam area, The Hague, and also here the Utrecht area in the center part of the Netherlands, sitting in a rural area where temperatures remains well below the 20 degrees. So this very clearly shows this urban heat island effect for this particular night. And clearly the health authorities are interested in maps like this when they want to do their analysis on how many people suffer from heat waves. It's interesting to have accurate information on where most of the people live in the cities. So one of the covariates we are using for this map is the urbanization, and then I've shown that particular one here on this slide. So this is data from the Corina land cover dataset, and on the left side you see a 2D map of the urbanization. So again, Rotterdam area here, Amsterdam area right there. And when you want to capture this 2D image in a one-dimensional histogram, you get the upper figure where no urbanization is on the left side of the diagram and completely urbanized is on the right side of the diagram. And this is how the Netherlands looks like in this histogram. And the center histogram shows you how the KNMI stations sample this urbanization. And clearly we sample this very poorly. We don't have any stations in urbanized countries, and that is a WMO requirement. So many Met services will not have that. The lower diagram shows you how this crowdsourced data sample this urbanization, and you see this is much more similar than what the KNMI stations produce, and much more similar to the real situation. So this clearly shows the benefits of using crowdsourced data when it comes to mapping out the urban climate. So I've added a picture here on how we do this. You can, much of the data from the crowdsourced data has a strong noise component, of course. One way of doing that is simply by ignoring all the crowdsourced data. And when you then interpolate between the official network, so these are the large squares in this diagram, you get very accurate values, of course, close to the Met service stations, but in between there's quite a bit of uncertainty. The completely opposite is to assume that the crowdsourced data are of equal fidelity, of equal quality as the Met service station, and then you get a picture like this, which is very, very noisy and also not, of course, what you want. You need to have a method which actually takes care of the situation that the crowdsourced data has a large noisy component. And the method we are using is called multi-fidelity regression, kriging. And what it does, it interpolates through the KNMI stations and uses the crowdsourced data more as a to give the pattern of, say, temperature in between these Met service stations. And in this approach, we are a bit inspired by the young daughter of our colleague Jouke, who came up with this method. And when his daughter goes to the daycare, she gets a plate of spaghetti and well, and needs to eat it, of course. And perhaps she doesn't like the vegetables and she wants to pick it out, but that's not how we raise our kids. We say to them, well, this is what you get, right? And what you get is what you get. This is what you eat. And I think we should have the same approach when it comes to data. So there can be quite a bit of noise, of course, in this crowdsourced data, but what we need to do is find a method which actually can cope with this data rather than applying strong quality controls to remove as much of the noise as we can. And actually, we try to demonstrate that in a paper which we published last year. Here we compare a simple nearest neighbor interpolation with this multi-fidelity regression kriging method. And of course, you can say nearest neighbor, that is very, very simple. And that's true, of course, it's very simple. But it's used also very, very strongly. So when you have storm damage, for instance, on your house, you call to the insurance agency, and what they do is they look at the nearest KNMI station. And that is also nearest neighbor interpolation. So when you use nearest neighbor interpolation and you use only the first party data, so only the data from the Met service, and you look at the cross-validation root mean square error, you get a box and whisker diagram like this. When you add the raw third party data, the citizen science observations, with the noise, you get, of course, a picture which is shown here, where the root mean square error actually increases. That is not a surprise. That's what you expect. When you then apply a quality control routine, what you see is that you recover a little bit from this poor behavior, but you're not at the same level as using only first-party data. And in this case, the quality control routine we have used is developed by colleagues from the Belgian Met Service. It's a method which uses physical limits and consistency arguments and also a body check. So it's quite an advanced method. However, when you are using this multi-fidelity regression kriging approach and using only the first party data, you get a picture like this, doing already quite a bit better than nearest neighbor. And of course, that is because of the kriging approach. Now, when you include the third-party data unfiltered, you're actually doing better than using only first-party data. And when you then apply a quality control, you're not doing even better. No, it's the result actually deteriorates. So this gives you interesting discussions on the need for quality control when it comes to crowdsourced data. So that is a touchy subject, and there is quite some energetic, so to say, discussions within KNMI on how to approach this. Now, in the final few slides, I'd like to show you a little bit about the approach on moving upward towards Europe. And I have one example for that. There is another example in the making, but the results were just too preliminary to show them here, so I'm afraid you need to wait for that. What you're seeing here is a data set which we bought from NetAtmo for rain gauges, so it gives you tens of thousands of stations providing 5-minute precipitation data. The network is very dense in some countries and not so dense in others, so it's very inhomogeneous, but the number of stations is very, very high, so much higher than all the combined stations of the Met services together. And I think it is a demonstration that the use of this crowdsourced data will change the data landscape for the Met services. And one application you can use is using this NetAtmo rain gauge data to calibrate the Opera pan-European radar data, and that is what one of our colleagues did using this data. So what you see in these diagrams is the distance from a radar to the nearest rain gauge using the network of official rain gauges. And the right map gives you the same, but then the distance from the radar to the nearest NetAtmo rain gauge. And clearly what you see is that this distance is much, much shorter. So the density of the networks is much higher, and also the potential to give you a more realistic precipitation field is there. And that's also shown in these bias diagrams here. What is shown here is the 1 hour precipitation, and then the relative bias is shown in these maps using the opera radar. So that is all European radars combined. That's on the left, and on the right you see this opera radar, but then using the NetAtmo stations to calibrate the radar reflectivity and providing an estimate of this 1 hour precipitation data. And what you see is that there is quite a bit of a negative bias in the opera radar, so it underestimates the total amount of precipitation of this 1 hour precipitation. But using the NetAtmo data, what you see is that this picture becomes much more towards the yellow or the bluish colors, giving you a much smaller bias in this 1 hour precipitation signal. So, coming to the end of the webinar, I think there are a few things to note, which explain my enthusiasm for using citizen observations in weather services for the Met Service. I think it can be a great resource. So the examples from MetNo show that in forecasting it improves skill and it gives a bias correction of the numerical weather forecasts. And you can also use it for monitoring. It adds detail, I think, and it decreases the uncertainty. And what we see is that there are interesting discussions when it comes to the need for quality control for these crowdsourced data. But I think one thing which is clear is that with these emerging new data sets, the landscape of data that the Met Service can use for their weather services is really changing. So it's time to hop on the running train and make use of this data set. Thank you very much for your attention.
Thank you very much for this very interesting presentation. And yes, we have a question from Liz Bentley. Thanks for the excellent talk, very interesting. It's great to see the additional detail and reduced uncertainty achieved using the additional observations. Are you using IA to analyze this additional data, or could the data be used in machine learning?
Yeah, that's an excellent question, of course, and I didn't really speak about it, but there is a bit of AI in this particular method. So if I can, wait a minute, that's the wrong time. Yeah. So I've shown you this slide, and I want to pay a little bit attention to the uncertainty here. And so you see the uncertainty is high over these forested areas. So we did an experiment by adding only one station from these forested areas. So we have one of the universities in the Netherlands. They have a research site in this forested area, and we added that one site to the network of WOW. And what happened? No, we added that one station, sorry, to the KNMI stations. So we assumed it was a high-fidelity station. And what happened is that the uncertainty over the forested areas decreased considerably. So the actual temperature estimate didn't change that much, only slightly. But the largest difference was found in the uncertainty of the forested areas. And what the method does, it actually learns itself how to behave in forested areas. So by adding only one station in a forested areas, your method benefits over all forested areas in the over the map. So that's also, I think, an interesting an approach. So by having a targeted project, for instance, trying to add lots of stations in one particular city, not only that particular city will benefit from a better monitoring and higher accuracy, but as you teach the relation between urban climates and the observations, also other other cities will benefit from this. So I think there is really a potential to improve our weather services using this methodology. Thank you.
Thank you. There are 3 questions from Monica Lakatosh. First of all, do you contact the amateur observers somehow if the measurements are inaccurate?
But, not really. So we do see that some of the observations are located in very poor conditions. The WOW network allows for a bit of differentiation between that. So it has a grading system to see which stations are better located than others. We're not using that grading system, to be honest, and there is not much of a feedback to the users. And that is a bit of a missed opportunity, to be honest. As I tried to mention in the introduction, many of the municipalities and also the state government, at least in the Netherlands, is very interested in getting citizens involved in this, in measuring their natural surroundings. And I think it's wonderful if you can use those observations in products of the Met Service. So in the Netherlands, and I think also in other countries, we see this erosion of trust between the state government and civilians. And by using data from civilians in products of the state government, I think we can perhaps work on this erosion a little bit. And that involves also having a dialogue with these users. So I think it would be a wonderful way forward if we would move to a situation where we would have the resources to communicate with these users and see, well, you're not doing that great with your station, with your personal weather station. What might be the problem? So I think that would be a wonderful way forward. But at the moment, we're not doing that.
Okay, and do you store the crowdsources data in the KNMI database?
At the moment, we're not doing that. At the moment, we're not mixing in the database the crowdsourced data with the KNMI station. So there's a physically separate database for that. That is changing, by the way. And one of the institutes in Europe, that's Meteo Swiss, has changed some years ago already. Their network is already very heterogeneous. So they have data from Meteo Swiss, but data from many other sources as well. And they all store that in their, what they call their data warehouse. So I think they are much more advanced in mixing those data in their database, more advanced than many other Met services in Europe.
Okay, and do you think crowdsources data is applicable for climate services as well?
Yeah, that is a good question. So when I look at the WOW station, this started 10 years ago, and at the start of this initiative, the number of stations was very small. So having long periods where we can use this data is, well, that simply doesn't exist. And perhaps we can extend it a little bit to using second-party data, which may have a longer history, but well, that will not bring us to, say, 30 years or 50 years or so. So I'm not so sure. There may be other methods where we use the patterns over the last few years and use those typical patterns to reconstruct say, temperature towards the past. But that clearly is a field of research, and so it would be a bit premature to talk about that, to be honest.
And there is another question from Michael Levitsky. He thanks for the presentation, and he asked, do you categorize, in a way, amateur stations in terms of their accuracy? Would it be useful as some of them might be better localized? Or
yeah,
something like that?
That's a good question. So when you look at the right figure here, what you see is that some of these, of course, this is a cartoon, so it's a bit of an abstraction, but it illustrates the point well. What you see is that some of these crowdsourced data are a bit outside the ensemble, and others are much more inside this ensemble. So also in this cartoon, you can see crowdsourced data which have a large bias and others which have a much smaller bias. So the method itself determines a little bit which stations contribute more and which stations contribute less in this approach. We have not tried to make categorization beforehand, so leaving out some stations or not. We did that using, as I tried to explain, using some quality control routines. That is not really about the location or categorization of amateur stations. But I think by leaving out stations, even stations which you think are quite poor, it also removes some of the signal. So I'm a bit hesitant to do that. What is interesting though is that we could stimulate civilians in poorly sampled areas, and that really would add to the quality of the maps. So that is something which you are thinking about very strongly, is to make focused activities to try to stimulate people in certain areas where we now hardly have any crowdsourced data, to see if we can persuade them to have a personal weather station in their back garden. So that would be the approach forward, I think.
This is actually agreed with the question of Gudrun Nina Petersen. She said, I see that there are a lot of WOW stations in the Netherlands. Did you have a campaign to get Dutch stations into the network? So you already answered a little bit.
Yeah. Well, most of the stations actually arrived there because people thought it was interesting, and not because we asked them to do so. So I think that is also a sign that people like to contribute to this type of activity. So I think we could use that very strongly. Yeah.
Okay, I don't see any questions more. Before closing this session, I would like to invite all of you to our next webinar, which is the last in this year, which will be on 10th of December, about Croatian meteorology in philately, presented by Marko and Višnjica Vučetić. And thank you, Gerard, once again, and thank to all you participants. See you on 10th of December.
Thank you for your attention, and thank you, Vesna, for hosting this webinar.
It was my pleasure.